Morning, folks. Hope everyone's okay. Sorry, I thought something was going wrong then because it wasn't giving me my normal stream data and everything else. So but it looks like it should be working okay. Brilliant. So the last lesson before half term. I won't be doing any next week at all, but I will carry on after half term. Although I think there's some other plans and announcements coming out from school as well. But I'm going to keep these going because I really want to build up a bank of videos to go through all of the topics. So one way or the other, we will finish these because I think it'd be quite good revision resources for you. Morning, Tanishka. Morning, Amy. So we're going to finish off Physics 1 today, so the energy topic. We need to look at energy resources in terms of renewable and non-renewable. It's probably the area that most of you are most familiar with, so that part of it won't take too long. And then I thought what we would do after that, I've got a load of exam questions that I've dropped on here as well. So we'll go through, we'll have a look at those, we'll have a look at answering some of those, and then we'll see what time we finish. So I'm not anticipating taking the full hour today, because this is really just sort of wrapping up the whole of the topic that we've done so far. So, brilliant. Let's make a start then. We'll just bring that over just so I can see that people are chatting. There we go. So, in terms of our energy resources, we know for a fact that generally we have either renewable or non-renewable. So the definition that we put down is quite important here. Lots of people seem to put down that renewable energy sources can be used again, and that's not true, and you'll lose the marks in an exam question for that one. Yes, renewable energy sources are better, but it's because they are either being or can be replenished. In other words, we can get more of them depending on what the energy resource is, but it's not that we can use the same energy resource again, because obviously we've already transferred that into something different. So from a physics point of view, that doesn't make sense. So the wording that we put down is very, very careful on that one. So that's for our renewable, and I'll just put that down here. So we've got that down as our notes. So renewable energy source is being or can be replenished. When we're looking at non-renewable then, they're the ones that we cannot replenish easily. So let's just look at some examples for this. If we're looking at our renewable, we are looking at any sort of biogas or biofuel. Now, we could be looking at wood here, because actually we can grow trees over a fairly short period of time, so we can produce more wood quite quickly. Charcoal, not coal, charcoal could be considered a biofuel, because again we can produce more of it. Now there are some environmental issues that we can talk about, but that would work here. If we are looking at, morning Olivia, if we are looking at ways of working with sort of biogases, then actually some of our waste materials we can actually use to produce more biogas. And some countries, what they've looked at is actually putting in sort of biogas generators where they can put sort of animal waste, human waste, food waste, everything else in, and they can actually run stoves in sort of some of the huts, some of the villages on some of this biogas, rather than having to rely on some other methods as well. So it becomes a bit more sustainable then. So biofuel is one form of renewable because it sort of meets this definition that it's either being or can be replenished, but we're not using the same energy again. We're going to look at a few more of these in a bit more detail as we go through. Obviously we know about wind energy, geothermal. Geothermal is an interesting one. Geothermal, it uses sort of heat underground. So anywhere where we may have magma or where we've got the heat sort of from deep underground meeting water, the water's going to get heated, and we've either got hot water or ideally we've got steam. And that steam can then turn a turbine and we can generate electricity. Or in the case of the Marlin Centre in Southampton, so the shopping centre, anyone that's sort of been there notices the sort of other side of West Quay, there's a red building and that actually says geothermal on it. And you can have a look, and that actually produces the heating in the winter for the Marlin Centre. So we do have geothermal in Southampton. Countries like Iceland have invested heavily in geothermal. Absolutely amazing what they've done. They have, because they have a lot of volcanic activity, they have access to a lot of geothermal energy. So lots and lots of water gets heated up deep underground. That comes up, turns turbines, produces electricity for the country. Now, as far as I'm aware, they don't burn any fossil fuels for the production of electricity, only in cars. So the wastewater from the geothermal power stations then gets pumped into all of the homes, into industries, and that produces the hot water and the heating for all the houses. And then the wastewater for that, before it sort of gets pumped out to waste and treated, gets pumped under the pavements because it's still hot enough to keep them de-iced. So they invest a lot in geothermal, but then their population is much, much lower. So their population for the whole of the country is about the same size as Southampton. Morning, Chris. So geothermal we've got, we can have hydro. Normally when we're looking at hydroelectric, we are looking at a reservoir somewhere, some form of dam or some way of pumping that reservoir or letting the reservoir drop down through the dam and again turning turbines. And we'll have a quick look at this in a moment. Tidal and wave are both different. And we have solar. So we've got these sort of main types as we're going through, and they are very, very different down there. Hang on. I'm surprised I don't do that more. I've got a habit as I'm talking and writing of saying what I'm writing, writing what I'm saying rather than what I'm actually thinking. So let's put that down as waves. So when we're looking at non-renewable, we're looking at energy sources, that is a W, honest. We're looking at energy sources that cannot be quickly or easily replenished. So yes, technically we could make more fossil fuels, but the time span they're produced over is over so many hundreds of thousands of years that we could not make it in a way that's convenient or easily. So therefore they're considered as non-renewable. So when we're looking at these ones, we are looking at coal, we're looking at oil, we're looking at gases such as methane that are not biogas, and we're looking at nuclear. So these ones are our fossil fuels. Okay, so we've got these ideas down as well. Now we need to be able to talk about the advantages and disadvantages of each of these. There are quite a few sort of long mark, 6 mark questions or multi-part questions where they're getting you to compare one of these fuel types to another. Now there is a brilliant website, and I'm just going to put this up here now, which is this one. So I'll leave those on the notes when I post them up on Google Classroom later on. It's not a new website by any stretch. It's been around for, well, I've been using it pretty much as long as I've been teaching, I think. But it's got every type of energy resource on there, what they are, how they're used, the advantages, the disadvantages, all of the information you've got. So if you want to go through more of this after I've finished, you can go through, click on the energy types and work your way through. And it really is an excellent website indeed. Yeah, so have a look at that. So when we're looking at, so let's have a look at some of these ones. Biofuels, we still have an emission. Now, remember when we're looking at the advantages and disadvantages, and I'm not going to go close to the word debate now because I know some of you will get way too excited at the thought of doing a debate on this. We might be able to do that once we get some of the online classes going. When we start looking at these ones, we need to look at the environmental impact to start with. So by that one, we could be looking at emissions such as CO2. So remember, we're looking at fossil fuels and we're looking at biofuels. They will all produce CO2. Now, the advantage of biofuels is, depending on where the fuel comes from, that carbon dioxide is generally taken in as the organic life is growing. So if we are looking at plants, if we're looking at trees, if we're looking at producing from them, as they grow, they take in carbon dioxide. And then as we burn them or as we produce the biofuel, that CO2 is then released. So I was waiting for that, Olivia. So over a short period of time, we end up with a carbon neutral. So these ones, we are looking at carbon neutral. And that is definitely a term that you need to be aware of, okay? Many businesses now are trying to have trees planted, they're trying to reduce the emissions from transport, etc., and things like this, in order for the business to become more carbon neutral. In a lot of cases, they can't reduce by completely all of the carbon dioxide they're producing from usage of electricity, use of people travelling to work, and all of these sorts of things. But what they can do is they can offset it, because if they know how much carbon dioxide is being taken in as trees grow, they can work out roughly how many they need to plant to offset as much as they can. I think it's IKEA are trying to become completely carbon neutral, so they have absolutely no carbon impact on the carbon dioxide levels of the world, and it's one of the things they're aiming to get towards. So CO2 is quite important. We may want to look at sort of wildlife and the ecosystems. So when you're looking at things like wind power, for instance, one of the reasons that people don't like wind farms is there is damage to birds as they fly through them. So what they have said is they found quite a few birds of prey that have been killed because they've gone through, and although those blades look like they're turning quite slowly, often they're actually spinning over 100 mile an hour. And as the birds go through, they get hit by one of those, and that causes, obviously, the bird to die. So we need to think about that as well. We may want to think about the impacts of noise. So I don't particularly have a problem, but some people that live near wind turbines seem to think they're quite loud, and they think there's a noise pollution aspect to them as well. So we may want to consider that when we're looking at these. The same way with some of the other forms, you may get additional noise if we're actually using wave power. So if we've got things going up and down, if you're living nearby, you may have an increase in noise levels from that one. If we're looking at the sort of non-renewable forms, again, if you're looking at things like coal, oil and gas, we've got a big transport issue because we have to transport the fuels to that. So as soon as you get a big transport issue, we're then looking at increased CO2 production, but we're also got the noise of additional trucks, of trains, of those transport as well. Just to go alongside that then, we've also not just the environmental, we're looking at the sort of, I'm going to put down business here for the moment. And these are all the different things that we can sort of bring in. Obviously, we've got the financial cost. So if we're looking at the sort of the coal and oil and the transport, yes, it's noisy. Yes, we're producing CO2, so it's bad for the environment. But we're also creating jobs. So we're actually giving those people that are driving those trucks, that are doing those jobs, so we're bringing in money that way as well. People that are then travelling to and from different places will also be spending money in those. So it can actually increase the economy of places nearby where there might be power stations there. So we've got to try and think outside the box a little bit as well with this. So it's worth thinking of that. Alongside the sort of business, we may also want to think of the sort of production and disposal. And I'm going to sort of move between these areas as we look. So production and disposal. And you'll see this in some of the questions that I'm going to look at in a moment. If we're looking at building sort of power stations that burns fossil fuels, generally they're quite cheap to build and to get rid of. Whereas nuclear power stations are going to be very expensive to build, very expensive to get rid of, but the actual running costs of them could be quite low. So we need to think about that as well. If we have power stations in sort of tidal environments in the sea, the maintenance costs is normally much, much higher because the salt water causes huge amounts of corrosion, and because it is in water, the maintenance is actually harder to get to. So the maintenance cost goes up. So we end up sort of trying to work through this balance with them. So we've got to think about that as well. Going back to the wildlife for a minute, if we're looking at different types of maybe tidal power, is there going to be an issue with the fish? A lot of the times nowadays they'll actually design them so it shouldn't cause any damage, but that may be with small fish. With bigger ones, I don't know. So it's all of these sorts of things that you can bring into your arguments, that sort of debate that you're going to have on the papers. And if they're getting you to do any form of evaluation, then you're going to be looking at the advantages, you're going to be looking at the disadvantages, and you're going to need to give your opinion based on that. So you're always going to make a claim, you're going to give the evidence for your claim, and then you're going to reason through that in your explanation. But even with science, you can still do that in bullet points if you need to. So it's not a problem doing that, or break it down into subheadings, or do it as a table with 2 different columns and work your way through. So don't ever worry about doing that as well. So these are the sort of different things you can look at. Okay? So we've looked at that. Okay, we looked at. I'm going to put maintenance down here as well, just that if you look back through these notes, you will see we've sort of spoken about that. Safety. I'll put safety down here. There are lots of people that worry, particularly with nuclear. Everyone's heard of Chernobyl. We know that one of the issues with Chernobyl is it went into sort of chain reaction, went into critical meltdown, and caused widespread destruction. And in fact, the area is still uninhabited now. There are people going back to visit. There are people spending short amounts of time. But recently, they've had to do a lot of repair work to the old reactors because there is still radiation leaking out of them. So even though they dumped lots of concrete on it after the explosion happened, what they are doing now is they're creating a giant concrete sarcophagus that they can actually roll over the top, because the old concrete is crumbling due to the radiation, which risks leaking it again. So we've got this sort of safety, and that comes into the environmental impact as well. In Japan, we had the sort of Fukushima reactor. That was caused by one of the main safety pumps getting knocked out, which means there wasn't enough cooling water going over the reactor. And again, we had issues there. So we have this sort of safety side that we do have to be aware of here. Again, it may be something else if you're having a discussion that you want to bring into your notes there. So make sure that you can consider all of these advantages and disadvantages when you're looking at them. Now, what I want to do is go through and have a look at some example exam questions, both on this and some of the previous topics that we've had. And we can sort of see and, well, talk about some of the issues that may arise when we're answering them. Okay, I thought I was on the right one. Let's go into this one. There we go. So you'll load up. There we go. So, don't be surprised, unless you've spent a lot of time reading around and looking at all the different power stations out there, and just generally keeping yourselves up to date with current science, current sort of information that's out and about. Don't be surprised if they sort of put something in that you may not have seen before. So with this one, if you've heard of the Archimedean screw, brilliant. If you haven't, you can work out pretty much what's going on using the information they give you. So this is a small scale micro hydroelectric. So this could be done on a small river, near someone's house. There's lots of sort of different ways that we could look at using this one. We're not looking at powering entire cities with it. So on a much smaller scale. It's using our Archimedean screw, which rotates. Now remember, with pretty much all forms of electricity generation, apart from solar, we are looking at having some way of spinning a generator. And when we have a look at electricity, and when we have a look at electromagnets, and when we have a look at how generators work, we'll go into this in a little bit more detail why that's important. But as long as we have this generator spinning, and there'll be a magnet spinning around in here, we're going to have electricity production happening. So what the purpose of this is as the water is flowing through this Archimedean screw, it is going to be causing it to turn. And we've got this word rotate. So even if we didn't know that, it's given us that information in the question. And then as it rotates, it's going to cause the generator to turn, which means we're going to get electricity production. So part one with this one is asking us to look at our energy types that we know, so our energy stores and our energy transfers. We've got GPE of the falling water. So the water is up here. It's going to a lower level. So we've got gravitational potential energy. It's causing this Archimedean screw to move. And anytime we see the word movement, we're going to have kinetic energy. So quite quick, quite easy for 1 mark. In terms of efficiency, remember we said this the other day, useful energy out divided by total energy in. So let's have a look at the information they've given us. Each second, the generator transforms 80,000 joules of GPE. Remember, GPE is at the front, so that's our 80,000 into 60,000 joules of electrical energy. So this is the output. So our calculation is going to be this. Now, if we weren't too sure with this one, remember that we don't ever want to get a number above 1 when we do this calculation. Because if we've gone above 1, we've made a mistake. Because that means we've managed to create energy from somewhere, and we know that we cannot create energy. So we should end up with a value of 0.75, which is 75% efficient. So I can multiply that by 100 to get 75%. Now, the question may then start to say, well, where does the rest of this energy, where has the energy gone? Because we know that it can't be destroyed. And we can start talking about friction. We can start talking about some of the water that may not be turning the screw. We can see there's a gap down here. And we can start talking about or coming up with ideas as to where some of the other energy has been transformed into. And actually, any sensible suggestion here will get you marks for this one. I know for a fact with this question, it then goes on to say, if this was, what are the issues with scaling this up to a much bigger level? Well, of course, the bigger we scale it up, the more energy that we're actually going to be losing in terms of wastage. So we start losing efficiency, so we may want to come up with a different idea. So these sort of things start thinking about with this one. There we go. Let's have a go look at another one. So, another question here. Again, reading it through, there's a bit of background information. Nothing too important to start with. The map shows the position of 2 towns on either side of a very large coastal bay. It shows where a bridge may be built to link the towns. The road journey from one town to the other is about 60 kilometres, so long just to go from this short distance at present. It's estimated that building turbines and generators inside the legs of the bridge would produce enough electricity for both towns. Well, that's quite important. In addition, there'd be enough electricity to run electric buses over the bridge. If the bridge is built, what from a renewable? Now, if we go back up to our list here, most of these we can discount straight away. The only 3 involving water are these 3 here. So we need to think about which one is most likely. And because, back down again, because we've got this bay, we've got the sea, it's going to be tidal. It's not generally going to be waves because the waves are going to be production. Yeah, no problem, Tanisha. I'll see if I can put a Sankey diagram question in towards the end. Okay, so it's probably going to be a bit protected for waves. So the only real option here is going to be tidal. And what that means is that as the water, so if you think about having some form of sort of barrier here, and inside that there will be some turbines. And the water can move through from one side to the other. Now what happens is at high tide, we end up with a higher water level than the other. So the water then runs through these turbines, turning them until they get to the same level. Now that does mean that generally at low tide and high tide, for about an hour each time, there's going to be very little electricity transferred here. What it does mean though is then as the tide direction changes, what we end up with, if we do the same thing just very quickly again, we then end up with high tide on this side, low tide on this side, so the water runs the other way. So as long as we have this tide changing, we're going to be generating electricity. So this answer here is going to be tidal. And it says most people live in the area in favour. Well, actually, realistically, there isn't a reason not to be in favour for this one, unless you just don't like the idea of a bridge. 3 reasons why people would be in favour, and you can literally let your imaginations go with this. Any sensible suggestion will be accepted. It's going to be quicker to get from one town to the next. There will be less pollution in the area because you're going to have the electric buses. It's going to be an environmentally friendly power sources. So we can start bringing in all of these sorts of ideas, and I wouldn't write a sentence. I would literally just do 3 bullet points, and I would walk away from that question nice and easy with that. You're not going to get any additional marks by trying to answer it as you would a question in English and writing big sentences and paragraphs. 3 bullet points, move away with it. Okay? Right, so have a look at another one. Like I said, I've got a few of these I thought we'd work through today because it's the sort of last lesson in this topic. Let's make it a little bit bigger. There we go. Now, fracking is a topic that isn't specifically mentioned that we have to cover. So there is enough information in this. It has been in the news quite a bit. So it is something that you should be able to talk about. But if not, there is enough information in the question to be able to get some of the marks for this. So we're looking at this idea of gas. If we don't know what the word shale means, let's ignore it for the moment. So we know that it's a natural gas trapped in rocks. Evidence that fracking causes minor earthquakes. That's obviously going to be a disadvantage. If we know other ideas about this as well, we can use them. Burning shale adds carbon dioxide. So straight away, they've given us 2 disadvantages in the question that we could use if we knew nothing about fracking at all. When we're talking about the advantages of nuclear then, we should know some things about nuclear. That is in the specification, and the exam board says directly that you should be able to talk about it. And that's the reason they haven't given us any information about nuclear. So with a fracking, because it's not explicitly mentioned in the spec that we have to know lots about, they've given us 2 disadvantages that we can use in our answer. So what I would do with this one, and 2 different ways of doing it, we can either do fracking and nuclear, and then do a series of bullet points, or we could do subheadings and we could do advantages and disadvantages. So depending on how you want to lay it out is entirely up to you with this one. But what I would do is plan your answer slightly so that when you go through, it sort of makes sense. And don't be afraid to ask for additional paper in the exams where you can draft out some of your answers on this one. You can do brainstorming. If you're looking at the notes and going, I haven't got enough notes to do that one, you are allowed to ask for additional paper. Obviously, you'll need to put the question number, you need to put your names and everything else onto that paper. But if you do something and it is literally just a brain dump onto the paper, then you can always put a line through it afterwards to say you don't want it marked. But if it helps organise your thoughts, do what is ever is needed for you. Don't be worried about anyone else. If you need that paper, just go for it. So already we've got the disadvantages with this one. We've got this idea that we've got increased CO2. And we've got the possibility of earthquakes. Now, you may have seen in the news, you may have seen on TV, other options with this, and don't be afraid of putting those down. That's absolutely fine. But I would also make sure you've included the 2 they've already given you, because that's going to be easy marks. If we're looking at disadvantages of nuclear, we've got disposal of nuclear waste. We could have the safety side. We could have the idea that people don't like the idea of nuclear. So we could put that down as well. And the number of these that I put down would depend on how many marks this question's out of. And the thing is, most of the advantages are going to be linked to the disadvantages. So you could always write this out as fracking produces CO2 that nuclear power stations do not. So therefore, we're actually combining some of those ideas. And we're looking at the advantages of one being the disadvantage of the other, and vice versa with that. Okay? So just things to think about there. But the big problem that a lot of people have is they get a question about something they haven't seen before and they start to panic. And usually there's enough information in the question. And actually, if you do start doing some form of mind map or brainstorm onto the paper, in a lot of cases, your thoughts will start becoming a bit more coherent and you'll be able to get some marks for this. So I thought what I'd do as well is I'd have a look at some of the calculations we've been looking at and just show you how they work in the question, because there's quite a bit of information here. And most of the actual formulas in this topic generally are based on the kinetic energy, the gravitational potential and power. So those are the ones we're sort of just going to focus on. and I thought it would just be good to have a look at a bit of a practice on this. So don't be afraid if you're watching this either after the lesson, so you're not watching it live, or you're coming back to it at a later session, to pause this and have a go at the questions before I go through the working out. So things we've got here, wind speed with a volume of that passes over each second, density of air. Calculate the mass. So one of the formulas we do need to know is the formula for density. And remember, density is how much stuff you've got inside, and I don't normally use that word stuff because I don't like it, but it's the sort of mass you've got contained within a particular volume. So the more particles you've got in the same space, the higher the density is going to be. So density is mass over volume. And remember the first thing I said whenever we're answering questions like this. I'm going to put meters cubed, or we can put centimeters cubed, depending on how we're doing it. Kilograms per meters cubed. So depending on how we're doing this one, we always write the formula out first. Then I can substitute in. Remember, it's 3 marks. So there's probably going to be a rearrangement on this one. So I've got 1.2 kilograms per meters cubed equals a volume I've got here, 2.3 times 10 to the power of 4. Remember, standard form, again, it's one of those areas it's coming in. It's going to be in almost every paper, pretty much guaranteed that at some point during your GCSEs, you will have a question that includes standard form in science. And that's not even including maths. So make sure you get your heads around it and you have a go at that. So what we don't know is the mass. So to rearrange this, that's going to be 1.2 divided by, sorry, no, it's not. Not paying attention. Let's go back. 1.2 multiplied by 2.3 times 10 to the 4. So I can give this, it doesn't specifically say in standard form. I can give my answer in standard form if I would like to. Or I can give it in any other value. So some questions say it specifically has to be in standard form. My answer would be, with this one, 2.76 times 10 to the 4 kilograms, making sure I've got the units correct as well. As we go on to the next bit then, it may need this one, it may not. I'll have a look. The power output of the turbine is directly proportional to the kinetic energy passing over the blades each second. Describe the effect on the power output when the wind speed is halved. So, if you're struggling with this one, don't be afraid to put data in. Remember, power equals energy divided by time. So that's one of the formulas they're talking about us using. The other one we've got in here is kinetic energy equals half times mass times velocity squared. So if I double the mass, I double the KE. Because I've got this squared here, if I double the velocity, I quadruple the kinetic energy. And the really key bit here is the power is directly proportional to the kinetic energy. So describe the effect when the wind speed is halved. So if we halve the wind speed, the kinetic energy is going to decrease by a quarter. Okay, and if you don't believe me, put some data in. I only have to describe this, so it's qualitative rather than quantitative. But it's one of those things in the exam, if you're not sure, but you can remember the formula, put some data in. Make up some really easy data. Call the mass 1 kilogram. Call the velocity 10. Okay, and work out the kinetic energy. And then what happens if you drop the velocity from 10 meters per second down to 5? And you get an idea. So we should be able to see that it drops by a quarter. And you can go through and you can do those calculations. So in other words, because this is directly proportional, if the KE drops by a quarter, and I'm just doing this in shorthand because you don't want to see me spend ages writing sentences out. If the kinetic energy drops by a quarter, the power also drops by a quarter. So decreasing the wind speed by half decreases the power output by a quarter. At a different speed then, the power, and this is going to be a slightly higher marking question, so let's have a look. The power output, and and sometimes what I find really useful, and it's what I used to do when I was doing exams, is I would actually go through and list key bits of data they've given me. So power is 388 kilowatts. And if you wanted to just put that in to start with, I don't know if it's going to be used yet because I haven't read the rest of the question. That's 388,000 watts. The mass, 13,800 kilograms. And it doesn't take long to write this out. I don't know the speed, so my velocity is my unknown here. And it's 100% efficient. And the key bit of information that I actually missed when I read that a second ago is that it's going to be each second. So if we know that power in watts is energy divided by time, then I can make the assumption here for 100% efficiency that in 1 second we're going to be using 388,000 joules of energy. So now, when I go back to my kinetic energy equation, and I'm doing exactly the same again, I'm writing it out. We can go through, it's the velocity we need, so I've got 3,888,000. I'm glad I converted it into watts now, because that's what I'm going to need for this bit. Equals a half times my mass, which is 13,800, times V squared. So, let's just rearrange that. So I'm going to go through and work that out to start with. Where's my calculator gone? There it is. So that equals 56.2. And remember, I've got the square to take into account, so I'm going to need to square root that. So my final answer is 7.5 meters per second. There's quite a few parts to this. So again, write down what you know. And I've always done this. I've done it since GCSE. I've gone through the question and I've just made a list of the data that I've known. And then sometimes what I'd also do is I'll go through and I'll make a list of any question that could be relevant, because then I can actually try and work out which equations I'm actually going to use. So we'll do lots of practice on this as we go through. You've still got just under a year, said that deliberately, just under a year before your exams. So we've got time to practice, but it is important that you do practice. Right, next one. That was that one. Have we done this one yet? No. Not going to apologise for lots of calculations. This is physics and it is a bit of a summary lesson. I just want to give you the opportunity to see some more calculations being done. So, slightly different format for this question. We've got the student doing chin-ups. Seriously need to lose enough weight to be able to do chin-ups. Right. 60 seconds. Let's have a look at what I've got. So I've got a distance here of 0.4 meters. I have a mass of 65 kilograms. And then we've got gravity. Okay, now I know what's going to happen. Gravity is 10 newtons per kilogram. So we want to know the power. So power is energy divided by time. So we need to realistically know here. We know the time is 60 seconds. We don't know the energy. So that's the thing we're going to work out. Because they've given me gravity, it makes sense to use this formula to work out the gravitational potential. So I'm going to substitute in. His mass is 65 kilograms. We know it's 0.4 meters, and they've told us that gravity is 10. So we're going to plug that into the calculator, because by now you're going to be sick and tired of me saying it. You will have your own calculator in the exam. There we go. Equals 260. Key thing, he did 12 chin-ups. So if he's going to be using 260, or if he's going to be putting in 260 joules of energy to pull himself up once, he's doing it 12 times. Okay, so I need to multiply that by 12. So times 12 reps equals so that's the total amount of energy. And I can plug that into there, 3120, which means my power output, if I divide that by 60, is 52 watts. Okay? How many more of these are done? I don't have to go through all of these, but I think it's probably useful for some of you. Now, I'm going to come back to that one when we do electricity. Okay. Now, this is the sort of thing that a lot of students switch off with and really shouldn't do, because they actually give us quite a bit of information. But I've said this to a lot of you that I teach. I've said before, it's really important to read as much as you can. Now, I'm not just plugging that because I'm a teacher and I think reading's important. I'm plugging this because actually a lot of the exam papers will be pitched at a reading age of 16. Some of them will have some questions lower, but the more you can understand of the questions, the easier you're going to find things. So it's really important for you to go through and just read as much as you can, whether it's papers, whether it's newspapers, whatever, and keep your reading ages high. So let's have a quick look through. We've got a population of a small island. So none of that's relevant. Off the coast of Scotland. The word coast could be important because it indicates that we're going to have sea around us. Decides to generate all of their electricity from water and wind. Okay, so they're going completely renewable here. Did not predict having a long period of warm, dry weather. So warm and dry meant low water levels and hardly any wind. So they had very low output. Explain one way the islanders could try and reduce similar. Again, any sensible suggestion with this one? Personally, I would turn around and I would, in this case, have some form of backup in either fossil fuels or wood or charcoal or coal. Something like that they could use. There's no point in putting anything silly down like nuclear because it's a small island, it's never going to get used. So what they're talking about is I would have a backup power station or generator. You could even do small power generators for each of the houses, depending on how big the island is, and a stockpile of fuel. And I would talk about that, and I'd move on to the next question. So there's a lot of information in here, but we don't need to worry about too much. They just want to back up. So Backup generator, I would put in a petrol generator or a wood generator, and I would have a backup of fuel stores just in case this happens. Last one. Stop cheering when I say last one. Now, similar questions we've looked at before. This looks really cool. So the miners working in a salt mine. See, I would have got stuck here going, actually, I really want to go on that slide. The miners working in a salt mine use smooth wooden slides to move quickly from one level to another. The miner weighs 90 kilograms. Calculate the change in GPE. They give us the strength of gravity and they give us the height. Same as before, GP equals mass times height times gravity. So 90 times 15 times 10. Okay. And it's energy, so I'm going to put that in there. So that's 2 marks that took me about 10-15 seconds to go through and do. With repetition, these things get much, much easier. Now, the difficult part of the question. Calculate the maximum possible speed. This is the same question that I did before. So, kinetic energy. And plug in the information we know. Rearrange. Go through a little bit quicker because we've done this before. I could have just written 45 in there, but I don't want people to go, where'd you get that answer from? So let's just type that in. So that answer's 300. Remember, it's squared, so I've got to square root that. So my final answer is 17.3 meters per second. And that would be a 3 marker at least for that last bit, maybe more. It wouldn't be any more than 4 because they split the question into 2 parts. So we've already got 2 marks for the GPE here. If they did it as one question, then it'd be worth at least 5 marks. So you're still getting the same marks, but they've been nice enough to break this one down. But if you notice, it's exactly the same working out. So with practice, these get quite quick. Right. Tanishka asked one more time to have a quick look at Sankey diagrams. So I'm just going to put that here. And then you'll be pleased to hear I'll be finished until after half term. So let me just put this in a grid. Let's try that one. There we go. No, it's not working now. Okay, I'll just have to use the grid squares in the back. Apologies if you can't see these very well, but I will work with it. Let's make up an example. Okay, well, I'll tell you what. Let's go with the one we had before. They said we had the Archimedean screw. They said we had 80,000 joules in. We had 60,000 joules out, which means we've got 20,000 joules as waste. So I need to work out some form of scale. So I'll tell you what, we'll do one of these squares that you can just about see will be 10,000. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 squares down. So 8 squares equals 80 kilojoules. We said that the length of the line didn't matter, so I'll just go out as long as I need to on there. The useful is 60,000, so this one needs to be 6 joules. 1, 2, 3, 4, 5, 6. And I can convert that into my array. My downwards waste arrow has to be 2 squares because 20,000 joules. 1, 2. And join it up. So we've got 2 squares equals 20. I've put kilojoules as waste. We've got 6 squares equals 60 kilojoules useful output. So it's all about getting the scale and then working out the width of the arrow. Okay. Right. I think I'm going to leave it there for now with that. I will upload these as normal. What we need to try and do is we need to try and get enough people together to have a go at a Google Classroom meet. I don't mind doing it next week because I'm aware that next week is half term, so I'm more than happy to wait till after half term. We need to start trying to rally more people, get more people online, more people working. There will be more information coming out, but actually the more work that we can do online at the moment, the more we can do. We're going to start covering a lot more new content soon. We don't know how long this is going to go on for. Like I said, there are plans in place which you will find out about in the near future. But that will be supplementing some of the work we're doing as well. So do try and encourage people that are not currently online, they're not watching these videos, they're maybe not doing other things, to get online, start watching them, and to get them involved in Google Classroom when I get this up and running. I say up and running, it's there now, because we want to try and make it as popular as possible, because it's the best way that we can then start doing presentations, we can do Q&As, we can do debates, and we can really start doing some face-to-face learning. As I said at the start of the video, I'm going to be continuing. Yeah, it will be a Google Classroom debate, Olivia. But it'll also be question and answered. So if there's things that I've covered in these videos that you're still not sure about, we can sit there and bounce ideas off and we can do some proper discussions. I can do the presentations and PowerPoints as well, and I can share them with you. So we can actually do some formal lessons, but I'm still going to keep these going as a bank of revision resources as well. So please do encourage other people to get online as much as possible. Access these, the ones I've already done and the ones in the future, and get them onto Google Classroom. And if anyone's struggling, get them to email me and I'll help them out. Anyway, if I don't see you before, have a great half term, and we'll definitely be up and running straight away afterwards. All the best.